This presentation will look at quantitative scenario modeling and will be presented by myself. In this presentation, we'll be looking at the broad purpose of the method alongside the practical guidelines and useful tools for implementing the method. Quantitative scenario modeling can be an effective means to communicate with and influence decision makers using quantitative and statistical data. These models reduce reliance on intuition as they have an objective foundation in the data. They help decision makers consider the implications of various uncertainties and factors in complex decisions and understand which of these is the most important and effective to use. Further, they can leverage visualizations and clear narratives to distill complex data for multiple scenarios into comparable insights. This slide shows the practical guidelines for implementing the method, and in the next slides, we'll go through a case study to show how it can be used in practice.
The case study we will focus on explores the following research question. Does material waste from solar PV development pose a waste management problem? Firstly, we need to outline the objective, but also consider our biases. In this case, we want to provide clarity to policymakers on the size and relevance of the material waste, but we also need to make sure that we don't assume that this waste is a burden before conducting the study. Secondly, we need to outline the scope. A suitable choice in this case would be to limit to installed projects in South Africa and up into a timescale of 2030. So here we've limited the system boundaries and scope in terms of geographical location, in terms of timescale, and also the sources of material waste that we will be considering. So for example, we're not taking into account uninstalled equipment, which might be quite difficult to track when those material actually enter the waste stream. Thirdly, we need to use trustworthy data sources. In this case, we've chosen reputable industry bodies and governmental bodies that track install capacity, such as the Department of Mineral Resources and Energy in South Africa and the National Industry Association for Solar PV. Fourth, in terms of selecting the scenario choice, so through an interview process, engaging with policymakers, we entered into a process of understanding which scenarios would be most relevant to them and most relevant to their decision. In this case, we've chosen the status quo if they were not to act. In incentivized waste management scenario, so if they were to implement a policy to make waste management of this waste more economical, and then thirdly, around the planned allocations in the integrated resource plan, which outlines how much solar PV can be installed by regulation, and comparing a fast versus a slow uptake. And this would influence how much waste is entering the system. So those were the three scenarios chosen. Fifth, in terms of tool selection, a number of various tools were considered, such as Google Sheets and Tableau, which are suitable because they provide a mix of numerical and visual focus, but also experimenting with other tools within the suite of potential quantitative tools, such as Vensim, which was used to explore the potential insights that might arise out of interactions of the material flow around key elements, which might include the cost of logistics and actors within the waste management and renewable energy sectors. In terms of item number 6 or guideline number 6, iterative feedback. So once we had selected the scenario and visually display them in terms of tools, we then retested the results against the same policymaker interview group, and what had resulted is that they would like to see a better visualization of how this waste material is developing over time, and as a result we have chosen to extend the time scale, so providing a time scale up to 2030, but then also up to 2050 when the waste potentially becomes more of a consideration having more of the waste having entered the waste stream. In the next slide, I will be going through some considerations around the visualization. This is an example of a bad visualization for our case study. It is a Excel sheet generated graph depicting the waste horizon for this solar PV waste up until 2050 in South Africa, based on the current IRP. What it communicates to the audience and of policymakers is that most of the waste generated is glass, and this waste increases over time, but it does not communicate the relevance of the waste generated to the capacity to manage it, and it does not communicate whether the amount of waste is substantial or problematic. This, on the other hand, would be examples of strong visualizations for our case study. Looking at the first example, the first example makes the magnitude of waste generated relatable and conceivable, using dump trucks as a metric as opposed to tons, which can be quite obscure. On the second, on the right, we have a map visualization. This could indicate the relevance of the location of waste to the locations of recycling hubs to indicate more nuanced challenges in the waste management, and can also emergently or through participant feedback highlight the relevance of logistics and cost in solar waste management.
These are some of the tools you can use in your modeling exercise. Some of them work best for numerical data focus, some of them for an interaction focus, some work for visual focus, and some work for a conditioning focus. So in conclusion, as we noted in the previous slide, it is very important that you use the appropriate tools to implement this method. What about challenges? Well, for this method, it is very important for you to maintain objectivity and not get carried away. For the future, what do we need to develop this method further? We need more training and more effective use of the tools, the right tools, and even identifying those tools. So training is very important. Due to the diversity of tools and methods within this quantitative scenario modeling, it can be a flexible means to influence decision makers, but scenario and tool selection requires careful consideration.